Okay, so let's give a little background about what Cornell notes are. Basically, what you do is there's a question. There's a question, yes. Introductory question. And after that question, we analyze information about that question. That's it. How easy is that? So, for example, our question one, or actually our essential question. So if you look on your 2 pages, we're focusing on the first page today, okay? And it says, essential question, how is energy unleashed? How is energy unleashed? From atoms. That's our goal. That's the main focus of this entire chapter, actually. How do we create energy? Right? I mean, solar power is good, right? We have solar power. We have wind energy. We have water energy. But are they effective? Not quite. They're getting there, but they're not quite. So how is energy unleashed? That's our main focus. So let's break it down to a few questions. Oh, man. Yeah, we'll make do with it. Okay. I'm going to turn off the front lights so you can see a little bit. Okay. So, question number 1. Topic question number 1. Topic question number 1. What particles make up the nucleus? Okay, I feel like we probably already know this. I think we actually even talked about this. What particles make up the nucleus of an atom? Well, the nucleus of an atom is composed of 2 subatomic particles. 2 subatomic particles. Okay? Those 2 subatomic particles are the protons, which are positive, and the neutrons, which are neutral. We already knew that. Okay. So the overall charge, I don't know why this is on here. The overall charge, what would the overall charge be? If half of it's neutral, the other half is positive, the overall charge is positive. Very good. The overall charge is positive. Okay. The overall charge is positive. This represents the nucleus of beryllium. Oh. Okay. This represents the nucleus of beryllium because there are 4 protons equal to the atomic number. There are 5 neutrons in this isotope of beryllium. Okay? So if you look at this, protons are positive. So there's 1, 2, 3, 4 protons. 1, 2, 3, 4, 5 neutrons. Beautiful. Bada bing, bada boom. So can we answer our question? What particles make up the atom, the nucleus of an atom? Can we answer that? Protons and there we go. I feel like we got question number 1 done.
Yes.
We good?
Oh, we're really good.
Good to move on?
We're really good.
Okay, let's do it. Let's do it. Okay. So, question number 2. Let's see if we can do question number 2, just like we did question number 1. Question number 2. What is an What is an isotope of an atom. An isotope is atoms of the same element. I'm not liking my markers today. Atoms of the same element that have different numbers of neutrons. Okay, atoms of the same element that have different numbers of neutrons. Okay, so if you count up how many positives, you don't have to color them, how many positives is in this guy right here on the left? How many positives? You can count on your paper. I'll count up here.
6.
I have to agree. I got 16. Is that what you guys got? So 16 positives. How many how many neutrons are there? I got 16. Is that what you guys are getting? So 16 protons, 16 neutrons. If you add up those two numbers together, 16 and 16, 32, that is its mass. Okay, now, if we said it has 16 protons, what element is it? Maybe sulfur? Sulfur has 16. Sulfur 16, right? Now, try the other two. How many protons? How many neutrons? Count them out. Here we go. Count them out. Some of them are hiding. We got 16 and 18. We got 18. Is that what you guys got? Okay, okay. So this is once again sulfur. What's this mass now? What's its mass going to be? If these two, 34. Very good. You just add the two numbers together. All right, last one. Let's try it out. I assume 16 positives because it's still sulfur. How many neutrons? Got 24.
This one is
Really? Is there 25?
far side, yeah, right there.
Maybe I'm missing a few. Are you guys getting 25? Is that what you guys are getting? Perfect. 25. So if you add up those two numbers, 41. That has a mass of 41. Okay. So question number 2. What is an isotope of an atom? Are we able to answer that question? Well, it's the same element, sulfur, sulfur, sulfur. However, they all have different masses. That's an isotope. We good with question number 2? We good with question 2? Okay. Last question. Last one we're going to look at today. Last question. Well, that's kind of cool looking with all the numbers. Kind of like connect the dots. I love doing those. Last question of the day is, what is nuclear fusion? What is nuclear fusion and how does it happen? What is fusion? Now, fusion, we don't know how to do fusion yet, right? We're still kind of like, we're in the planning phase, right? Let's see, if you turn it to the side, fuse stems from a Latin, means to melt, all right? When we think of something really hot, what do we think of? Fire, right? Now, another thing you might think of is that it takes place in the sun and the stars. So fusion actually takes place in the sun. So whenever you think of the sun, you think of nuclear fusion. Okay? Because with high temperature and pressure, we need high temperature and pressure, lighter nuclei combine to form a large nucleus. So fusion, one way to think about it, fusion, two things fusing together. It's as easy as that, two things fusing together. However, fission, it's just the opposite, it kind of breaks apart. Let's see, what else do we need? Needs temperature of over 10 million degrees Celsius. 10 million, okay. That's pretty hot. No wonder why it needs to be on the sun. But how in the world are we trying to do it here on Earth? 10 million degrees Celsius. It's like 5 degrees Celsius outside right now. How are we supposed to get 10 million? That's pretty crazy. Crazy stuff. Okay. Can I move on? All right, last slide of the day. Okay. Last slide. Okay. So, as we already know, we need pressure, we need heat, we need the isotope of hydrogen with one neutron is called deuterium. So we need deuterium. Okay? We need deuterium. Okay? In other words, H2. Okay? And what it creates is a helium nucleus that has 2 protons and 2 neutrons. Wait, hold up. A helium that has 2 protons, 2 neutrons. What is that? What do we call that? We just dealt with it on Thursday and Friday. What's a helium nucleus that has 2 protons, 2 neutrons? Alpha. Alpha, beta, gamma. That's an alpha. Right? We create an alpha particle from fusion. So awesome. Okay. Now, is alpha dangerous? Is alpha radiation dangerous? No. Not at all. Like, it'll just bounce right off our shirt. It won't do anything. So, the best part about this is it does not produce radioactive waste. It does not produce radioactive waste. Crazy stuff. So, what is nuclear fusion? Okay, nuclear fusion, we need a lot of heat, we need a lot of pressure. We're fusing 2 deuterium atoms together to create an alpha particle. Beautiful stuff. Ever good? Okay, that is it for today. Okay, that's it. All right, now with the remainder time, we got 18 minutes, so we have half a class. All right, half a class. What I want you guys to do is we are completing some missing work today. All right, this is the only. Okay, the rest of the week we're going to be pretty busy. Pretty busy. All right, so use this time wisely. If you need a computer to check progress book, please check progress book. I did not grade too many things over the weekend, so if you turned it in after Friday, after school, I did not get to it yet. Okay. Okay.